Well, for this problem, you want to use under Chapter 9, you want to use a hypothesis test for a mean, because this is testing average. Oops, here it says average. So the average salary in this city is $42,100. Is the average different for single people? 41 randomly selected single people who were surveyed had an average salary of $50,000 with a standard deviation of $16,740. What can be concluded at the alpha equaling 0.05 level of significance? So first thing, average salary is $42,100. Since it's an average and the sample size is over 30, but we're still using a t-test because the standard deviation is from the sample, not the population. The null and alternative hypothesis, the null is always equal to, so we know the center is equal to. Since this is mean, we use mean. If it was proportion, use the p. And then this value is the average salary, which is the $42,100. The alternative, the beginning and the end, are both the same as the null hypothesis. The thing that changes is what you're testing. This one will, H sub 1 will never be equal to. It's one of the other three. It says, is the average different for single people? So it's not saying greater or less, it's just saying different. So that's not equal to. Then we plug our values into the table to find the test statistic, the p-value. Our sample size was 41. The population mean comes from the null hypothesis, 42,100. Oops, it didn't hit enter. Okay. Sample mean was the 50,024. Standard deviation 16,740. And alpha's 0.05. So then our test statistic is t, and 3.031. P-value, this was two-tailed, so 0.004. They want 4 decimal places, so 0.0043. Now you want, oops, I shouldn't hit that yet, but you want to compare the p-value with alpha. And notice p-value is less than alpha, so less than or equal to. If p is less than alpha, reject the null hypothesis. So we reject. The data suggests that the population mean is significantly different. It's significantly different because we're rejecting the null hypothesis. So there's statistically significant evidence to conclude that the population mean salary is different from the 42,100 because we rejected. And then when you're interpreting the p-value, you use your as a percent, so we multiply this by 100. And that's how they got the 0.43. If the population mean salary of single is 42,100, and if another 41 singles are surveyed, then there would be 0.426% chance that the sample mean of these would either be less than or greater than, because we were testing not equal to. Interpret the level of significance in the context of the study. Level of significance is the 0.05 that we were given. And if the population mean salary for singles is 42,000 and another 41 singles are surveyed, there's a 5% chance that we would falsely conclude that the salary is different. So it's telling you if that was true, there's a 5% chance you would say it wasn't.